Hello and welcome to this PPSD tutorial. Today's session is a demo of the PPSD module. Let's get started. So the first thing you need to fit a PPSD to your data is dissolution in different conditions for a single batch of product. This example, I have a batch called WO27180. It's a 100 milligram ankylobresnine capsule. And I have already added a few of the dissolution data. I'm going to just to add another one with you here. So you go to the observed data in GastroPlus, you select in vitro dissolution release, create, or you select your batch name, and then you add your measurement. So here we're going to call it pH 6.8, 0.2% SDS. When we have created this series, if you scroll down, you can see it appears here as a blank table. You need to be careful with the units, move it to the right units before you copy and paste, and then you can select from your input data, you can select your dissolution and both columns, time and percent dissolve. Control C for copy, and then right click in the first line of the table and paste. You can now see all of the input data overlaid, and you can compare with the previous data. Scrolling further down, you need to also indicate the amount of drug that was used in the dissolution, which is here 100 milligram capsule, the volume of the dissolution medium 900. You can put the pH here 6.8 and the solubility 0.62. Once you've done that, you also need to generate some formulations. So here in the dosing part of GastroPlus, you need to make sure you have the right formulation for this exercise. So in this case, I have already created my 100 milligram capsule here. Moving to the PPSD module, you have three panels, the surfactant panels, which comprises a database of surfactant for which critical micelle concentrations and micelle radii were compiled from the literature. It's quite complete, but if you do not find your surfactant that you want to use in your dissolution medium, you can always add it by clicking on this button here. The next panel is called inputs. In this panel, you will add the new dissolution series that we have created. Click on add, give it a name. It should be a unique name representing both the formulation and the condition. So in my case is pH 6.8, 0.2% SDS. And once you've created that new line, you can then link it to the right group and series. So in this case, it's the right formulation and the right group, but the series is to be selected and matching the input name. So in this case, my raw data is 0.2% SDS, and I link it to my batch as well. So you can see I've already got the volume, the amount, the volume, the pH, which were taken from my observed data. Now for that particular dissolution and for all the new dissolution inputs that you add to the PPSD module, you need to have more details. So scrolling down, you can see that I have my input name. I know my medium is water, but I need to inform the surfactant. So just toggle that button on, select my SDS, and I need to give the CMC, the critical micelle concentration, micelle radius, the concentration of the medium, and the affinity of the drug to my surfactant. So all these values can be measured or calculated outside of GPX. I'm going to show you two tools. The first one is called Size and CMC Calculator, which you can download from the help. So if you click on this, you can select for SDS the temperature of the medium, the counter ion concentration here was 50 millimolar, and of course the surfactant concentration is 0.2% SDS. So you can see here my micelle radius is automatically calculated for me. I had to put the sodium concentration in the medium because it influences the radius of this ionic surfactant. It's the counterion of sodium dodecyl sulfate. So I'm going to use this radius. The CMC I can ignore because it's close to 0. So just remember these two values, concentration and the radius. Going back to GPX, I can put now my radius, 3.43. My CMC, I'll put it to 0, and my concentration, 6.9. So the last input parameter is the affinity of your drug. For this parameter, you need to measure the concentration, the apparent concentration of your drug in media comprising increasing concentrations of surfactant, which is this raw data here. If you know the CMC, you can indicate it, and if you don't know it, you can visually look at this evolution here. You can see that at the first concentration, I have an increase in my apparent solubility, drug solubility. So in this case, my CMC is close to 0. You can select this data and move to a second tool called the CAF fitting tool, which allows you to independently or simultaneously fit the affinity, the aqueous solubility, and the critical micelle concentration for raw data. I suggest you keep these default units, so concentration in millimolar for the surfactant, and solubility, apparent concentration for the drug in milligram per liter. This will allow you to get an affinity in milligram per millimolar, which is your input in GPX. In this case, I fitted a straight line starting from the aqueous solubility, no CMC is equal to 0, and my affinity is 81.61. Just going to use that input here, 81.61. The next input you can have is, so finishing with the solubility, you need to put the aqueous solubility here, the aqueous surface solubility for your drug, and you can see that my apparent solubility in 6.9 millimolar sodium dodecyl sulfate has been calculated automatically. Similarly, the fraction unbound, the drug that is available in the aqueous phase, has been calculated based on these two values here. The last three input parameters you can attach to that dissolution experiment is the assay of your drug product. If you have underdosing, overdosing, you can indicate it here. The disintegration time, if you have a capsule, which is the case here, you could put a disintegration time in vitro, and the degradation rate once your drug is solubilized. If it degrades in solution, you can put the first order rate constant. This is the first order degradation. And this is it. Once you've done that, you can go back up, and if you've done all these details for all your inputs, you can click on this button called Calculating Value. This button will actually look at all the experiments across a single drug formulation and select the experiments that are anticipated to lead to complete drug release, but with the lowest zinc value, and suggest that you use that experiment for fitting your PPSD, which is here the case for that latest input that we've just added. So the 0.2% SDS is what the module recommends for optimization. The other conditions are going to be used for model validation. So that's what we're going to do. If I collapse now this input and move to the runs, I can create a new run. So I'm going to call PPSD W02710. And once I've created this run, I link it to my formulation. The next input is the user-defined prediction tolerance, which is the error that you allow the solver to have when fitting the data. I would suggest you leave it at the default 10%. You can always come back to it, reduce it, and click on Fit again. When you click on Fitting, you can select the input you want for the fitting and then click on Fit. If you did not indicate any starting radius or mass fraction, the solver will try to find the best solution to your data according to the precision tolerance you've indicated. Here, the first solution gives you a 2-bin particle size distribution. The error is less than 10%, but we slightly overshoot. We want better. We can reduce the precision tolerance to 5% and click on Fit again. In this case, the solver will try to get closer to the data. The solution is here. less than 5%, we can see how that fares in terms of validation. Click on validation, you select the inputs that you did not use for the fitting and click on validate. The results are shown here. We have overall good prediction. The errors are less than 10% apart from the pH 6.8, which is slightly under predicted here. At this stage, you could decide to reduce the tolerance and click on fit again. You could manually change the radius. You could add a line, delete a line. If we, for example, reduce the radius to 13 micron and click on validate again, you can now see that the dissolution is well predicted. All my errors are less than 10 or even 5%. And so I could consider this as a good model, good enough model. You click on transfer. There's a message acknowledging the transfer. And now in the observed data under the particle size distribution, you can see a new group name called PPSD W2718001. This number 1 was added because it's the first transfer. If you were optimizing the feet and transferring again, it would be number 2, 3, etc. You can, of course, rename that group, get rid of the number 1. And this is your PPSD that you can use for predicting in vivo dissolution. Thank you for your attention. Have a good day. Bye.